Hey, welcome. My name is Nick Cody.
And I'm Trevor Owens.
And you're here viewing SHRMP. SHRMP stands for Supervised High Rate Metal Printing, which is basically a fancy way of saying we have a robot that's a 3D printer. Yeah, really simply, we have a MIG welder on the end of a robot and we're using it to 3D print molten metal.
Right here we have our camera, which is allowing us to do vision so we can assess the weld quality using computer vision algorithms. And behind this we have the laser scanner, which scans over the top of the weld and will tell us the heights and depths of the weld and allow us to adjust the speed for the next pass so we can get a flatter, smoother weld. So what we can see here is the point cloud that we just got out from our laser depth scanner. This is where we're going to send the robot along the path to weld.
What we're going to do is vary the speed of the robot so that at the hills it goes a little bit faster and at the valleys it goes a little bit slower, so effectively filling in or adding material wherever it needs to. So in our simulation what we've done is made spheres that correspond to the amount of material that we're depositing. So in this case you can sort of see we've got a fatter bead here where we've got a little bit of a valley, and a really large one here where we must have a small tear from maybe where we started and stopped. But in general what we're doing is governing the speed of the robot, the amperage, the wire feed speed, things like that in order to make the robot print more effectively.
The question is, how do we learn this speed function? Right now what we're using is laser scanning. We're also monitoring the amperage and the arc, and using all of these multiple sensing modalities we can actually train a deep reinforcement learning algorithm to predict these speeds, so it'll be able to create a cleaner, flatter weld than any of us at the lab would be able to do, short of doing a brute force search over all of these parameters.
If we can take the world, scan it, and then bring it back into the digital model, then we can know exactly what we've made. Meaning we know exactly what the structural conditions are of the exact weld that we just deposited. We know exactly what the materials are that we worked with. We know exactly the failures, the places where it might break. So this act of teaching the robot how to scan, bring back in, and then respond to the thing that it's making is just a piece of it. But the bigger picture is talking about taking the world and closing the gulf between that and the digital realm.